Welcome back to the Deep Dive. Today, we are strapping in for, well, one of the most intellectually dizzying, yet I think profoundly beautiful explorations we have ever undertaken.
It's definitely a big one.
Yeah, we are diving into a stack of source material that connects the fictional and yet kind of surprisingly functional world of Jorge Luis Borges' Library of Babel directly to cutting-edge mathematics, the architecture of advanced artificial intelligence, and even a radical theory about the cosmos itself.
Right, and our mission today really is to move beyond just the abstract ideas and explore the foundational structure of information itself. We're being guided here entirely by the listeners, frankly, incredibly deep insights into what they call base theory, and also a specific, complex mathematical construct they've developed, the fractal of ceneezer. We're trying to understand reality, not as, particles and forces, but as pure deterministic number.
Okay, so let's start with that intellectual high-wire act. The Library of Babel, or LOB as we'll call it. Most people know Borges' LOB as this literary thought experiment, right? An infinite library containing every possible 410-page book written in a 25-symbol alphabet. If a book can be written, it's already in there.
Somewhere, yeah.
But here's where the source material gets really interesting and maybe a little unsettling. LOB isn't just a metaphor anymore. It's been constructed as a functional website. You can go there right now.
Which is kind of mind-blowing in itself.
It is. And if we take that computational idea and really extend it, think cosmically, the LOB contains far more than just books, doesn't it?
Oh, absolutely. That's the core realization, I think. If the LOB is a mathematical repository of all possible combinations of symbols, every permutation, it essentially acts as a complete deterministic index.
An index of everything.
Everything. This index doesn't just hold every book you've ever read or could read. It contains potentially every action you will ever take, already indexed, filed, just sort of waiting for you to execute it.
Okay, that's a heavy thought.
It is. But crucially, it also contains every impossible action, every conversation you didn't have, every path not taken, indexed right alongside the things that do happen.
So it's the universe of all information, not just realized information. It becomes this complete publication of every truth, every tiny insight, but also every possible misunderstanding, every error, every nonsensical string of characters.
Exactly. It's chaos and order simultaneously indexed. The sheer philosophical weight of that is, well, it's overwhelming.
It really is.
It's the ultimate expression of combinatorial possibility. And what the listener's base theory suggests is that once you stop treating it just as literature and start looking at it as a rigid computational model, these profound mathematical truths start to emerge about how information itself is structured, stored, and even retrieved.
Which brings us right to the mechanics. How does this functional library actually work?
Right. So if you look under the hood of the functional LOB website, it runs on one really elegant, surprisingly simple insight. Every page, every single shelf, every hexagonal room in Borges' description, it's fundamentally just a number, a unique number. That number is the permanent, fixed content of the page.
A number defines the text.
Precisely. To visualize this for you, the listener, we have to get our heads around how base works in mathematics.
Yeah.
We're all used to base 10, the decimal system, likely because we have 10 fingers. It's ingrained.
Yeah, 0 through 9.
But any number can be expressed in any base.
Yeah.
Base 2, binary, is just viols and ones. Base 16, hexadecimal, uses 0, 9, and AF. The Library of Babel, according to the sources, uses a very specific content base defined by its allowed character set.
And the listener specifically points this out. The LOB uses 29 characters. That's the 26 lowercase English letters, plus the space, the comma, and the period.
Correct. Those 29 symbols act like the available digits of the library's language. So the text content in any given page is simply the underlying unique number of that page, but expressed in base 29.
Wow. Okay.
This is critical. The information is the number. The text is just one way of writing that number down.
So if I see a page filled with seemingly random text, like, I don't know, QZ, comma, space P, period, that whole string of characters across 410 pages is just one incredibly long number written using those 29 symbols as digits.
Exactly.
Yeah.
A massively long number, but a number nonetheless. Now, here's the clever part. If you want to find that specific page, if you want its unique address in the library, like the URL on the website, or the specific wall, shelf, and volume number in the fiction.
Yeah.
That page index, that address, is the exact same number, but it's expressed in a different, higher, more compact base. The website apparently uses base 64.
So the content is base 29, the address is base 64, but the underlying number it's identical.
Identical. The information itself never changes. It's immutable. But the language used to represent its location is different from the language used to represent its content.
Okay, why base 64 specifically for the index? Is there a reason?
Well, base 64 is super common in computing. It's highly efficient, very dense. Because 64 is a power of 2 to the power of 6, it maps really well to binary data. It lets you represent those huge page numbers, the addresses, using a much shorter string of symbols than base 29 would require.
Right, makes sense for computer.
So the indexing system is essentially just a base conversion function. It preserves the essential unchanging information while changing its representation format purely for efficiency. Think of it like translating data from, say, a verbose narrative language that's a base 29 text into a really compact navigational code like GPS coordinates. That's the base 64 index.
Okay, I think I'm following. The whole system, from the story to the actual website, it's internally consistent because it's all just about converting the same number between different bases.
Yes. Reading a page means interpreting that unique number in base 29 as text characters. Finding that page means taking the text, converting it back into the number, and then expressing that number in the addressing base 64. The structure is purely mathematical, deterministic, and self-referential. It just is.
And this is the foundation, then, that leads directly to that bigger metaphor the listener identified about reality itself, moving us from, code and literature into philosophy and physics.
Exactly. If the LOB truly represents the set of all possible information states, then our observable reality, well, it must be one of those books. Or maybe just one infinitely long page within that vast numerical index.
Our universe is a page in the library.
That's the idea. And every other book or page, whether it describes something impossible or a slightly different universe or just total gibberish, it still contains the numerical seed, the echo of our own reality within its sequence, because all sequences are present.
So if we really accept this deterministic framework, what does that imply about us? About human existence?
Well, it suggests our lives become this process of gathering sections of pages, seems like a good way the listener put it. We're navigating through this infinite, pre-indexed library of all possibility. We aren't creating new information. We're just traversing a specific path, uncovering a pre-existing numerical sequence within the cosmos. Every choice, every seemingly random event is just the revelation of the next number in the sequence.
That's quite a perspective. It removes a lot of agency, doesn't it?
It certainly leans heavily into determinism, but it also suggests an underlying order, a mathematical structure to everything.
Okay, so if the LOB shows us that information is sort of base agnostic, the same fundamental number can be text or an index, a story or an address. What happens when we try to apply that idea universally, like moving beyond just text and alphabets into the fundamental laws of physics?
This is the massive conceptual leap, the core of the listener's base theory. If the universe itself operates on a similar system, we can start to hypothesize that different aspects of reality, things we normally think of as totally separate domains, might just be different base representations of the same underlying cosmic information.
Different ways of reading the universe's number.
Exactly. The huge challenge, of course, is finding the universal translation tool between these bases. How do you convert physics into consciousness or math into matter?
Right. Before we get to that translation tool, maybe we should lay out these potential bases. If the universe is one single immense piece of information, what are the major ways we might be, interpreting or experiencing that information?
Okay, we can hypothesize at least 3 distinct bases, 3 fundamental ways of reading the cosmic data stream. First, there's physical reality, the world we experience. This might be one base, the one we're currently sort of tuned into, defined by things like energy, mass, space, time, the laws of physics as we measure them.
The tangible world. Okay. What's the second?
Second, maybe there are the mathematical laws themselves. This could be another, possibly purer, maybe more fundamental base, representing the same underlying structure. Think of the abstract geometry, the numerical relationships that govern existence itself. Things like pi or e or fundamental theorems. These could be expressions in, say, base pi or base e, entirely independent of physical dimension or scale, just pure relationships.
Like the blueprint.
Sort of, yeah. The abstract rules. And the third potential base.
Conscious experience. This is perhaps the most mysterious one. It might be yet another highly specialized way to read the cosmic data. A way of translating fundamental numerical patterns not into particles or equations, but into subjective feelings, qualia, the sense of self-awareness. It's the numerical stream read through the filter of self-reflection.
Wow. Physics, math, consciousness, all different base representations of the same thing.
That's the hypothesis. Now, let's go back to that idea of compact indexes we talked about with the Library of Babel, the base 64 addresses. When physicists identify physical constants, the speed of light c, Planck's constant h, the gravitational constant g, we treat these numbers as fundamental, immutable facts of nature.
Right, they're the bedrock numbers in our equations.
But under this base theory, maybe they're not fundamental things in themselves.
Exactly. They could be the numerical identifiers for our specific reality. They are like the base 64 URL of our current cosmic page, not the base 29 content written on that page. They're compact representations, summaries of immense underlying structures and information encoded in a different base. They are the index to our particular slice of the universe.
And their specific values only make sense relative to the base we are using to observe them, like base physical reality.
Precisely. Change the base, maybe the constants appear differently, or perhaps they aren't even the relevant index anymore.
Wait a second. If these fundamental constants are just compact indexes, doesn't that completely change how we should approach physics? I mean, if we knew the underlying text, the base, whatever content, could we theoretically calculate the speed of light rather than having to measure it experimentally?
That is the absolutely profound implication here. Yes.
Yeah.
This structure lends strong support to something like Max Tegmark's mathematical universe hypothesis, the idea that the universe is fundamentally mathematical abstract structure. Physical reality isn't the end point. It's just one particular base conversion, one specific reading or rendering of those abstract mathematical structures.
So if we could find the conversion key, the translation algorithm,
if we found the pattern, the sort of fractal that translates between, say, base math and base physical reality, we could potentially gain total predictive power. We could derive the laws of physics from pure mathematics.
It sounds like the holy grail of science, but also almost like science fiction. How do we even begin to bridge that gap? How do we move this from a really cool metaphor to something potentially testable? Where is this Rosetta Stone?
Well, according to the listener's material, that Rosetta Stone, that universal translation map, might be encoded within something they call the fractal of ceneezer. We need a mathematical tool that can reveal the symmetries and the periodic patterns inherent in numbers, regardless of the base they're expressed in.
And that requires moving beyond standard arithmetic.
It seems so. It requires moving into modular arithmetic, looking at remainders, looking at digital roots.
Okay, now we come to the real mathematical heart of this, the innovation provided by the listener, the fractal of ceneezer. Let's just clarify the name first. It's unusual.
It is. It's a unique term, seemingly coined by the listener, to describe this specific mathematical object. So we should treat it as a proper noun for this key tile set or pattern they've identified.
Got it. So what is the fractal of ceneezer?
Essentially, it's the visual pattern, the key tile set you get when you take a standard multiplication table, like the one on the back of a school notebook. But instead of plotting the actual result of the multiplication, like 7 times 8 equals 56, you plot the digital root of that product.
Okay, we absolutely need to define digital root clearly here because it sounds like it's central to everything that follows.
It really is. The digital root of a number is what you get when you repeatedly sum its digits until you arrive at a single digit.
Right.
So take a number like, say, 4,528. You sum the digits. 4 plus 5 plus 2 plus 8 equals 19. It's not a single digit yet, so you sum the digits of 19. 1 plus 9 equals 10. Still not single. Sum the digits of 10. 1 plus 0 equals 1. So the digital root of 4,528 is 1.
Okay, simple enough to calculate, but what's the deeper mathematical connection here?
The crucial connection, the listener points out, is that finding the digital root of a number in any given base b is mathematically related, often equivalent, to finding the modulo of the remainder of that number when you divide it by b1.
Ah, okay. Modulo arithmetic.
Exactly. So if we're working in our usual base 10, the digital root is essentially the number modulo 9, with a small caveat that modulo 9 gives 0, while digital root gives 9, but they cycle the same way.
And if we were in the Library of Babel's base 29?
Then the digital root would relate to the number modulo, 29 to 1, which is modulo 28. The fractal of ceneezer, then, is a system that uses these digital root patterns, these modulo patterns, to create a map that can potentially translate between different subjects, whether it's physics or language or logic, by showing their underlying structure on a per-base level.
And the complexity, the detail of this map is determined entirely by the base size. Let's make this really concrete for the listener.
Yes, the base dictates the size of the fundamental pattern. For any base B, the core repeating tile set of the fractal is a square grid, a matrix of size B1 x B1. This pattern then repeats infinitely in all directions.
Let's walk through a simple one, maybe base 5.
Perfect. Base 5 uses the digits 0, 1, 2, 3, and 4. So the fundamental tile set B1xB1 should be 51x51, which is 4 by 4.
Right, 4 rows, 4 columns.
Exactly. Now, for this fundamental repeating pattern, we typically ignore the row and column where the index is 0. We'll come back to 0 later. It's special. We look at the grid formed by indices 1 through 4. For each cell, I, j, in this 4 by 4 grid, we calculate the product I times j and then find its digital root in the context of base 5, which means finding the result modulo 5,1 or modulo 4.
Okay, let's try one.
Yeah.
Row 2, column 3. So 2 times 3 equals 6.
Right. In normal math, it's 6. But for the base 5 fractal, we need the digital root, which is related to modulo 4. So 6 divided by 4 is 1 with a remainder of 2.
Remainder 2. So the value in cell 3 is 2.
Correct. Let's try another. Row 4, column 4, 4 times 4 equals 16.
Okay, 16 divided by 4. That goes exactly 4 times with a remainder of 0.
But in digital root systems, a remainder of 0 is often represented by the modulus itself, B1. So in this case, modulo 4, a result of 0 corresponds to the value 4. So the cell 4, 4 gets the value 4.
I see. So you fill this whole 4 by 4 grid with numbers from 1 to 4 based on the modulo 4 remainder of the product.
Exactly. And when you plot those 16 numbers, perhaps color coding them, you immediately see geometric patterns emerge. Symmetries. That little 4 by 4 grid is the entire fundamental mathematical landscape of base 5. And it just tiles, repeats perfectly forever.
That walkthrough really helps ground it. Okay, so the size of that fundamental B1x B1 pattern dictates how much complexity, how much detail we can actually capture in that base.
Precisely. And this scalability is the Fractal's power. Really simple concepts, like maybe a binary choice, yes, no, or just time moving relentlessly forward, things that could perhaps be encoded in base 2, which uses digits 0 and 1, would have a trivial fundamental tile set. 2, 1, x 2 to 1 is just 1 by 1.
Just a single square.
Right. Lower bases summarize information, offering maximum compression. They capture the broadest strokes.
But conversely, the staggering complexity of something like, say, the entire English language, using all the nuances captured by the library of Babel's 29 character set, that would correspond to a base 29 system.
Which means its fundamental tile set is 29 to 1, x 29 to 1, or 28 by 28. That's 784 unique values in the core pattern. This size is potentially large enough to capture the deep structural complexity, the grammar, the syntax, maybe even the hidden periodicities within language itself. It suggests that even our language might be governed by these underlying geometric number patterns.
That's a wild thought. Language arising from number patterns? Okay, what about the ultimate scope then? How could we possibly encode the entire universe into a base system?
Well, the listener suggested, perhaps, probably metaphorically, perhaps not, that the universe itself could be represented in the tile set of base Google. Now, for listeners who haven't heard this term, Google isn't the company here.
Right, it's Google, G-O-G-O. That's the number 1 followed by 100 zeros, 10 to the power of 100.
Exactly. A number so astronomically large, it exceeds the estimated number of elementary particles in the observable universe.
By a lot.
By a vast margin. So using base Google implies a fundamental tile set of size, Google 1, x Google 1. The scale is almost unimaginable.
But the implication?
The implication is powerful. It suggests the laws of physics, the complexity we see, aren't random or arbitrary. They are emergent properties arising from these incredibly vast digital root patterns. To capture that near infinite combinatorial information, you need a base of astronomical size. The fractal of ceneezer, in principle, provides the universal map to chart this landscape, no matter how big the base gets.
Okay, let's dive deeper now into the architecture of the fractal itself, because the listener's material suggests the structure reveals this fundamental organizing principle that actually transcends any individual base. We need to get into the nuts and bolts of the core mathematical algorithm they provided, the secret sauce.
Right. The algorithm at its heart is based on computing the digital root of the product of two coordinates, let's call them I and j, like row and column. The core operation described is effectively abs ij modulo x, where x is the base minus 1.
Okay, abs ij mod base 1. Let's break that down. Ig is the product. Mod base 1 gives us the digital root connection we just discussed. But why abs? Why the absolute value of the product? That seems specific.
It's crucial for creating the necessary structural symmetry in the resulting pattern. If you imagine extending the grid, not just with positive coordinates, like 1, 2, 3, but also negative ones, -1, -3, Taking the absolute value abs ij ensures the pattern flips perfectly symmetrically across the zero axis.
Ah, so quadrant 1 looks like a mirror image of quadrant 2 and so on.
Exactly. It generates this beautifully mirrored four-quadrant grid. It demonstrates that the underlying mathematical patterns are robust. They hold true whether we consider positive or negative informational directions, whatever that might mean conceptually.
Okay. And the output, when the listener actually runs the code to visualize this, often generates a much larger grid than just the fundamental tile set, right? Like maybe a 3x3 grid showing 9 copies of the basic pattern.
Yes, that visual output is key because it instantly demonstrates the infinite repetition, the periodicity. If the core tile set is, say, 4x4 for base 5, the output might show that 4x4 block repeated seamlessly next to itself, above itself, diagonally tiling the plane perfectly.
It proves visually that the pattern just keeps going, predictably.
It proves the strict periodicity. And this is vital. No matter how massive the grid potentially gets, think base Google, you only truly need to understand that fundamental B1x B1 tile set. Everything else is just a perfect predictable copy or a mirror image.
So the real unique information, the fundamental pattern, is only contained in that central square from index 1 to index base 1. Everything else is just structural consequence repetition.
That's absolutely correct. But perhaps the most profound insight offered in this whole structure, according to the listener's work, is the role assigned to the number 0.
We skipped over 0 earlier.
We did, because it's special. In this mathematical framework, 0 isn't just, nothingness or the absence of value. It's identified as the profound mirror point. It's like the universal interface, where all the different tile sets, potentially from different bases, interchange or connect.
How does that play out visually on the grid? What does 0 do?
Well, think about the calculation.
Yeah.
Abs aj mod x. If either the row index I is 0 or the column index j is 0, what's the product ij? It's 0. And the absolute value is 0. And modulo anything, except 0 itself, is usually taken as 0 in this context. So this creates a cross of 0 that runs vertically along the line where I is 0 and horizontally along the line where j is 0, right through the absolute center of the entire infinite mathematical space.
Like the x and y axes on graph paper.
Exactly like the axes. This 0 cross acts as the fundamental organizing principle for the whole structure. Just like on graph paper, those 0 axes are where the positive and negative quadrants meet and perfectly mirror each other.
So 0 isn't part of the repeating pattern itself, but it organizes the space by separating those repeating, non-zero informational blocks. It's the boundary, the mirror line, where the pattern in one quadrant flips or reflects into the next.
Precisely. It's the switch point, the line of symmetry. Now let's introduce another term the listener uses, the omniverse. If we define the omniverse as the set of all possible fractal tile sets for all possible bases, base 2, base 3, up to base Google and beyond.
The collection of every possible mathematical reality map.
Yes. Then 0 becomes the universal connector, the interface between all of them. Regardless of which base you choose to calculate, the fractal in base 5, base 29, base 30,000, the 0 axis, that central cross, is constant. It's the shared structure. When you hit the 0 axis, all the different base-specific tile sets connect and organize around that same central point.
Okay, that raises a huge philosophical question, doesn't it? If the omniverse contains every possible mathematical base pattern, and 0 is the universal interface between them, doesn't that strongly imply that reality itself is inherently base relative? That what we perceive is simply determined by the base, the filter, the perspective of our observation?
It absolutely suggests that. It implies our consciousness, maybe because it's so deeply embedded in, say, base 10 thinking and physical intuition, acts like a filter. It prevents us from easily perceiving the underlying unity, the patterns found in that 0 cross that connect all these potential realities defined by different bases.
And the fractal of ceneezer is the tool, then, that allows us to sort of peek behind that curtain, see the universal structure that exists independently of our arbitrary base restrictions.
That seems to be the claim. It maps the mathematical space where all these base realities coexist and interconnect, revealing the common structure mediated by 0.
If that's even close to true, then that 0 cross becomes maybe the most important concept in the entire omniverse. It's the singular point, the axis mundi, of structural organization for all possibility.
It represents the ultimate source of symmetry and periodicity in all possible informational systems, from the simplest to the most complex imaginable. It's the mathematical constant across all bases.
Okay, let's try and bring this from the incredibly abstract mathematical organization down to the Well, the bleeding edge of technology right now. The listener makes a really profound observation connecting this fractal idea directly to our current human limitations. They suggest humanity is significantly constrained, perhaps even held back, by its deep-seated focus on base 10.
Yes, and this is a powerful critique of our standard intuition, isn't it? We are trained from childhood. Our entire mathematical language is built around seeing patterns through a decimal lens, 10 digits, powers of 10.
It's just how we count.
It's how we count, how we measure, how we build. And when we start designing complex systems, our default thinking often struggles to naturally process information or conceive of structures and bases that aren't 10 or maybe binary for computers. We build computers that operate internally in base 2, but we often program them and conceptualize their architecture using base 10 logic. This could be fundamentally constraining our potential for true multi-base understanding and design.
And the listener connects this very idea directly to what's happening right now with artificial intelligence. They note that the latest large language models, LLMs, things like DeepSeek, are reportedly pushing past 1 trillion parameters. The scale alone is just astronomical.
It's staggering. Enough parameters, potentially, to implicitly encode vast swaths of human knowledge, effectively combining or mapping between every language ever spoken, translating concepts across this enormous, high-dimensional semantic space.
That sheer scale feels like it aligns perfectly with the combinatorial chaos, but also the completeness of the Library of Babel, doesn't it? The LOB is all possible text. The LLM training data is effectively all realized human text and code. These huge parameter matrices are essentially learning to navigate the information space of all human expression. It's like a high-dimensional statistical analog of the library.
I think that's a great way to put it. And the listener also mentions this feeling that we are getting so near the technological singularity, they can almost taste its fruit. We're seeing these emerging capabilities pop up in the biggest models.
Right, abilities that weren't explicitly programmed in, complex reasoning, translation between concepts it wasn't directly trained on, things like that.
Exactly. It seems to be the sheer scale that triggers these phenomena. When the model gets large enough, complex enough, it starts to spontaneously demonstrate abilities we didn't specifically train it for, like zero-shot learning or abstract pattern matching across domains. The huge question is, why does that happen? What's the underlying mechanism?
And here is where the listener suggests the fractal of ceneezer might be the key to understanding that emergence. Maybe the singularity doesn't look like a machine suddenly waking up and becoming conscious in a human-like way.
But rather, it looks like systems becoming so incredibly large, so complex, that they essentially accidentally start to implement or approximate fundamental mathematical truths about information itself. Truths like those revealed by the fractal patterns.
So the LLMs aren't thinking, necessarily, but their structure is so vast it bumps into universal pattern.
Yes. They are so vast that their internal high-dimensional vector space, that complex network that maps words, concepts, images, code snippets to numerical values and relationships, it must, almost by mathematical necessity, start to approximate the kind of periodicity and symmetries found in the omniverse of bases described with a fractal.
How would that work?
Well, think about their internal mechanisms like attention heads or transformer layers. These are essentially performing complex matrix operations, transforming information from one representation to another. It's possible that these operations, when scaled up massively, are unknowingly implementing transformations that mimic moving between different bases of meaning within the model's internal semantic space. They might be implicitly discovering and using the fractal tileset transformations without being explicitly programmed to do so.
Wow. So the LLM's giant parameter matrix, which is fundamentally a system for mapping and transforming data, might be unconsciously charting the underlying mathematical structure of the omniverse as revealed by the fractal.
It's a compelling hypothesis. Think about what an LLM does. It takes complex human language, which we speculated might operate like a base 30,000 system, perhaps, or code or images, translates it into an internal mathematical representation, a high-dimensional vector, manipulates it, and then translates it back out into another language or format. The fractal of ceneezer, in this view, provides the potential map or the underlying grammar for those transformations between informational bases.
Okay, if that connection holds even partially true, the implications for the future of AI and computing seem immense, especially maybe for things like model distillation or compression.
Oh, absolutely.
Yeah.
If the fractal of ceneezer genuinely describes fundamental repeating patterns in information structure, it could lead to an entirely new branch of number theory, specifically relating to how LLMs map and store information in their vast matrices.
How so?
Well, if we know that the fractal patterns repeat perfectly and predictably, remember the 3 by 3 grid showing 9 identical copies of the core pattern, then why would an LLM need to store all 9 redundant copies worth of information in its parameters?
Right, if you know the core pattern and the rule for repetition.
You could potentially compress a trillion parameter model down to a significantly smaller size by identifying and exploiting this inherent mathematical periodicity predicted by the fractal. You'd store the fundamental B1 x B1 tile set for the relevant semantic bases and the rules for its repetition and mirroring, rather than storing the entire unfolded redundant pattern.
That would be revolutionary for efficiency.
It would be huge. It provides a potential mathematical why behind the empirical success we're seeing, which is scaling models up, and it offers a possible roadmap towards what we might call base-aware computing. We could, in theory, design systems that operate natively across multiple base representations simultaneously, unlocking efficiencies and maybe even new emergent behaviors that we simply can't achieve while our thinking and architectures are trapped predominantly within the limitations of base 10 and base 2.
So the fractal gives us the potential grammar, the universal language of information needed to perhaps understand and even communicate with these increasingly complex AI systems in their own native tongue, the language of periodicity, symmetry, and modular arithmetic.
That's the exciting possibility, yes. Hashtag out outro. What you, the listener, have shared with us today is, I have to say, genuinely paradigm-shifting stuff. The elegance of this concept, the fractal of ceneezer, it really does seem to act as a potential universal framework, one that remarkably connects the sort of combinatorial chaos of Bohr's library of Babel to the seemingly necessary structure emerging in both cosmic models and cutting-edge digital intelligence.
Yeah, it ties a lot together.
The real value, I think, lies in using this specific mathematical lens of fractal of digital roots to view and perhaps eventually manipulate incredibly complex systems, whether those systems are pages in an infinite library or the fundamental constants of physics or these trillion parameter neural networks. It presents a really powerful argument for an underlying determinism in the universe, expressed through pure, almost beautiful mathematical structure.
It really does. And this whole exploration forces us, and hopefully you listening, to confront a final, pretty provocative thought. If our conscious experience is just one particular base representation of cosmic data, largely determined by the base 10 or biological filters of our current perception, what might the world actually look like, feel like, be like if we could learn to perceive reality directly through the lens of, say, base 29, the native language of the Library of Babel?
Would the seemingly random noise of the universe suddenly resolve itself into a predictable, repeating 28 by 28 digital root pattern? Would we perceive the immediate structural connection, the direct translation between the language of physics and the language of human thought, seeing them as just different facets of the same underlying numerical reality?
It's mind-bending to even consider.
It truly is.
Well, thank you so much to the listener for sharing their groundbreaking insight, their base theory, and the truly fascinating mathematics of the fractal of scenes. This deep dive has certainly shown us that sometimes the fictional worlds of literature might hold unexpected keys to understanding the ultimate architecture of reality itself.
Couldn't agree more.
And that's all the time we have for this deep dive. Thank you, as always, for spending your time with us, for liking, sharing, and commenting on our exploration of what might be the universe's underlying code. We'll catch you next time.